is I did promise we're gonna do a little bit more work with fractional exponents. So I actually have a little warm up for you guys. And what I want you to do with this warm up is, since we're kind of jumping into this, I want you guys to work in like groups of 2, 3, or 4, and try to work together. It's two-sided. It's not graded, so don't worry about that. All right, why don't we go back to the front here? Sorry for making you do a bunch of work in the morning, but I think it kind of got us warmed up at least. So I got a couple of you to write down some of your answers. I'll go through some of them in more detail as well. Amara, do you kind of want to take us through number 1? Mhm. Perfect, perfect. I do want to explain more in detail on how we got from this step to this one. Amara said we multiplied the 2 exponents. If you're not good at fraction multiplication, which I'm not very good at it either, basically when we have a fraction multiplied by a whole number, I always like writing the whole number as a fraction as well. Okay, so 3, if 3 is in the numerator, what's in the denominator? 1, perfect. Multiply on top to get 3, multiply on bottom to get 2. That's how the fractions 3 has. Any questions on number 1? Perfect. Number 2, who wrote that one up? Yes, do you kind of want to take us through this one?
So for number 2, we are 5 to 7 and a higher power of 1/3. So you're going to multiply 2/3 by 1/3 to get 2 ninths, and 2 ninths converts to the 9th root of y.
Awesome job. Any questions on number 2? All right, then we got into a little bit more of a crazy type of question. Who wrote up number 3? Was that, oh gosh, don't tell me yet. Marissa? Yeah. Perfect. Marissa, do you want to take us through this one?
So I noticed there were 2 x's, so I did x plus 3 over 2, wait, x 3 over 2 plus 5 over 4, and then I did the y to the 1/2, and then 2, and then z to the 0 is 1, so I just wrote that there. And then I changed the denominator on the 3 over 2 to a 4, so I got 6 over 4 plus 5 over 4, so 11 over 4. And then, so that gave me x to the power of 11 over 4 with y to the 1/2 times 2. So then I just rewrote it as 2, and then the square root of x to the 11. How would you say that?
I would say the 4th root of x to the 11th.
Okay.
Yeah.
And then the square root of y.
Perfect, perfect. So this one was a little bit harder because there's a lot more terms. When we have 2 different exponents being multiplied together, that's when we do addition, right? So this is why we have addition. Addition's a little bit hard with fractions, but as long as you find a common denominator, we're good. Does anyone have any questions on number 3? Perfect. All right, let's flip over to number 4, which I left for myself because I actually wrote it down wrong on my notes for some reason. Let's talk about this one. We have a bunch of things being multiplied together. No exponents to an exponent. First of all, let's work with the numbers first, the 3 and the 4. What should I do with them? Just multiply them, right? Because they are kind of together. So I'm going to take the 3 and the 4, multiply them to get 12. Okay. Next, let's work with the variables. First of all, we have an m, right? We have 2 of these. Okay. So we want to have some sort of exponent on the m. What should I do with the powers of the m? Add or multiply? Add them together. So I want to add the exponent of this guy here times the exponent of this guy there. What's the exponent on that m? 1, right? This is technically m to the first power. So if I wanted to add these, I would take 1 plus 4/3. That's the addition I'm doing here. Okay. Next, we have two n's. There's an n here and an n here. We want to add those as well, right? So n to the 1/2 plus 1/2. Okay, good with me so far? Perfect. Okay, so on the side, I'm just going to do 1 plus 4/3 because I think that's kind of the hard part here. What's my common denominator? 3, right? I want to make the 1 a fraction out of 3 plus 4/3. What is 1 as a fraction over 3? 3/3, good. So 3/3 plus 4/3 is 7/3, right? So the exponent on the m has to be 7/3. I think we can do the n on our inner heads. What's a half plus a half? 1, perfect. So n to the first power. We can leave it as this. I don't really care. But let's just write the 7/3 as a root. The 3 is in the denominator, so that becomes in like the little cranny. M to the 7th. And we don't really need to write the 1 on the end, right? Okay. Any questions on number 4? Right, I'll let you keep writing if you haven't already. All right, I'm gonna flip on down to number 5. All right, do you want to snap a picture of it? Oh, okay. All right, perfect. So going down to number 5 here, who did I get to write this one up? I'm forgetting. Alex, do you want to take us through this one? Mm-hmm. 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 Awesome, awesome. If anyone wants to tell the class, how did we find out what 32 to the 1/5 is? Yes. Mhm. Perfect. So if you ever have a number raised to a power, sometimes it doesn't work very well, but if it comes out to like a whole number, test it into your calculator. Just write 32 caret and make sure the 1/5 is in parentheses, because if you don't put it in parentheses, it might kind of freak out on you. So make sure you write it that way. It should just give you the whole number. For this class, I'm going to try my best to make sure that it works out very nicely. So you're not given like a really weird test. Okay. Any questions on number 5? Do we feel a little bit more confident with fractional exponents? Maybe you need a little bit more practice, but you're good with like practicing on your own. Awesome. All right. Sounds good. So I will post the answers to this on my classes. So if you haven't written everything down, I will post them up. But for now, let's just go back to our notes from last time. All right. Does anyone need a copy of these notes? Oh. All right, so we talked about working with polynomials. We talked about what polynomials were. They were like a bunch of different variables being added together. So whenever you see like 2x plus 5, that's a polynomial. We talked about how we could add, subtract, multiply, even divide polynomials. And we did a little bit of work with that. And then we started this thing about factoring. So we talked about factoring polynomials by this technique that we called grouping. Let me just keep an eye on the time here. Okay, so the first thing we were given, let me here, was we were asked to factor this thing called 4ac plus 2bc minus 2ab minus 2b. The reason I knew this was a factoring by grouping problem is because we had 4 terms, so 4 things we added together. And if I like cut it in half, the first half shared a term and the second half also shared something, okay? Now, I know we're kind of jumping into this from last class, but I took a 2c out of the first half and I took a negative d out of the second half. Can someone remind me why I took a negative d instead of a positive d out of the second half? Riley?
You want those to match.
Yeah, like the whole goal of this factoring by grouping technique is so that the 2a plus b matches on the left and the right. So everything in the parentheses should match together, and that's kind of how you know you're on the right track. Okay, next we're going to talk about how we can kind of combine this together, okay? If this doesn't make sense, you might just want to memorize the process of doing this, but I'm kind of going to try to make it make sense. On the left, we have 2c of this group of 2a plus b, right? And on the right, we have negative d of 2a plus b, okay? And I have an idea. On the side here, I'm going to do a little scenario. So this doesn't have anything to do with this question, okay? So this is an alternate question. Okay, let's pretend I had 2 of 2a plus b, and I wanted to add 3 of 2a plus b. Okay, so this is just an alternate scenario. I think it's easy to figure out how we could combine the two. How many of 2a plus b do I have at the end? So if I wanted to simplify this into 2a plus b, it would be 5, right? Okay, if you don't see that, you can even think of this as taking 2 stars plus 3 stars. That would give you 5 stars, right? So 2a plus b is just something, and we have 2 of it, and we're adding on 3 of it, and we're getting 5. Alternatively, we have 2c of 2a plus b. We're adding on negative d of 2a plus b. If I were to combine this together, how many 2a plus b's do we have? 2c minus d, right? Okay. So technically what we're doing, we're kind of splitting up this 2a plus b. We have 2c of it, we have negative d of it. We can combine this together to 2 multiplied polynomials. Okay. Now, if that doesn't make quite sense to you, what really is important here is you're going to do this process. You're going to have a repeated sort of clump, like 2a plus b is repeated. Basically, factoring by grouping is taking the coefficients up front, making that one of your factors. Your other factor is going to be the repeated polynomial. Okay. This is our fully factored form. We took a big string of numbers and turned it into multiplication. Okay. Any questions? All right. The process of factoring by grouping kind of is the same for any grouping question. Why don't you give example 3 a try? I'll be around to kind of look at your answers. But yeah, I think we have enough time to do this. All right, so Will wrote up a really, really good answer here. Do you want to take us through your answer?
So first I exclude
Mm-hmm. Mm-hmm.
The other one, they share things.
Mm-hmm. Awesome, awesome job. Any questions on example number 3? Perfect. I'm actually going to let you guys out early because I have to walk over to Conway Hall for my next class. So I'm going to let you out a little bit early. Next time we'll talk about factoring a little bit more, and I will see you on Wednesday, right?